Advanced Algebra, Chapter 7, Lesson 1, and I want to do a short video where I do some examples of simplifying these radicals. And I'm going to jump right to these ones that have both numerical radicands and variable radicands together so that we can see how we can combine these together and simplify these. So again, I need to do the numbers different or separate from the variables, so I'll do that first. So 160, I'm going to, I'm probably going to need a little bit more room than that. I'm going to do my upside down prime factorization. So this is 2, 20, and then 10, and 2, and 5, and 5, and 1. Okay, so my index tells me that I need 5 of the same number in order for that to simplify to a single value. So I have 1, 2, 3, 4. So these 5 2's are going to simplify to a single 2. And then I have a radical 5 or a 5 prime factor left over. So the 2 is going to be able to come outside, and then I'm still going to have the fifth root of 5 underneath because I only have one 5. Now, to do the variable, remember we're simply going to divide this into 8. So 5 goes into 8 one time. So I have one A outside, and then I have a remainder of 3, or 3 that are left on the inside. So this would be the simplified version of the fifth root of 160 A to the 8th. Okay? I'm going to scroll down here to where I have the answers so we can double check our work as we're going through, and you can see we have that first one right. Okay, so let's go ahead and do number 5 here. So again, I have 256, which I'm going to need to do my prime factorization with. So I'm going to divide by 2, so that's going to be 128, and then 2 into that would be 64, 2 into that 32, 2 into that 16, 2 into that 8, 2 into that 4, 2 into that 2, and 2 into that 1. Okay, so my index tells me that I need 5 2's. So 1, 2, 3, 4. These 5 2's I can make as a single 2 on the outside. And then I have 3 2's that are left over. So I'm going to have 1 2 on the outside, and I'm going to have 3 2's on the inside, but I don't want to list them separately. I'll multiply them back together, so that's where I get the 8. 2 times 2 times 2. Now, for the letters, or for the variables, I'm simply going to divide 5 into this power. So I'm going to have 5 into 7 goes one time, and then I'm going to have 2 left over. So this would simplify to 2k, fifth root of 8k squared. All right? Jump over here to number 6. I'm doing a sixth root now. So again, I'm going to look at the number 512, and I'm going to prime factor this. So this would be 256, and 2 goes into that 128, and 2 into that 64, 32, 16, 8, 4, 2, and 1. Okay, so I need 6 2's to make a single one on the outside. So 1, 2, 3, 4, 5, 6. So these 6 2's make a single 2 on the outside, and then I have 3 left over, so those will continue to be on this inside, so I'll multiply those back together. 2 times 2 times 2 is 8. Then I can do the variables. So I'll go into M. So 6 goes into 7 one time with 1 left over. 6 does not go into 5 an even amount of time, so I have 5 left over, so all of them stay on the inside. 6 goes into P to the 8th, 6 into 8 one time with 2 left over, so this would be the simplified version. 2mp, 6th root, 8m, n to the 5th, p squared. You can see I have the same answer. So let me go ahead and do this one here, a 7th root, and again I'm going to do the number first, so I'm going to do 1024, and again I'm going to have to do my prime factorization. Let's see, it's 512, and 2 into that would be 256, and then 2 would be 128, and 2 would be into 64. And you can see we're seeing the same numbers over and over again, but we'll get used to this as we do it. But again, we need to realize how many 2's we have, so we have to keep doing this prime factorization like this, okay? So again, I need 7 2's now because the index is 7. So 1, 2, 3, 4, 5, 6, 7. So these 7 2's are going to be a single 2 on the outside. And then again, I have 3 left on the inside, so I'm going to multiply those back together and get 8. Then I can do the variable. So 7 into the 2 of the x doesn't go in. There's not enough, so that stays there. 7 into 9 goes one time with 2 left over. And then 7 goes into 8 one time with 1 left over. So this would be the simplified version. 2yz, 7 through to 8, x squared, y squared z. Okay, I would do one more and then we'll wrap this up. Let's do this one because this is something interesting. Now I notice that this is a cube root. It's an odd root, so a negative radicand is okay. Now, what you need to think of this as is this is actually a negative 1 times 256. And now I take the cube root of each one of these. The cube root of negative 1 is negative 1, so that's going to come out. And then I would do the 256 separately. So basically what that comes down to is this. Whenever you have a negative radicand and an odd root, the negative sign always comes outside. You will never have a negative radicand as a final answer because that negative sign can be viewed as a negative 1, and the cube root of negative 1 is negative 1. You can take the cube root of negative 1. So that negative sign will always come out no matter what. And you can see that it came out here. All right? I'm going to go ahead and do number 9 here down at the bottom so you can kind of see how that goes. Again, so I have negative 640. So I know the negative sign is going to come out because the negative sign always comes out. So then I'm just going to do my prime factorization with 640. So this would be 320, 160, 80, 40, 20, 10, 5, and 1. My index is a 7, so I need 7 2's. So 1, 2, 3, 4, 5, 6, 7. So all of these 2 come outside as a single 2. I have a 5 left over that can't come out because there's only one of them, so he has to stay inside. And then I can do the variables. 7 does not go into 4, so all 4 of these remain inside. 7 goes into 9 one time with 2 left over. And 7 does not go into 5, so all 5 of those stay inside. So I end up with then negative 2y, 7 through to 5x to the 4th, y squared, z to the 5th, and you can see that we have the final answer. Okay? Hope those were helpful for you, and we'll end that here and look at the next video.